Okay, a quick little video on mass, weight and gravity. So let's have a look. Alright, so to kick it off, what's the difference between mass and weight? Well, basically, we often have problems with this when we're teaching in the classroom because normally everyone refers to their weight as something that's measured in kilograms, and it's actually wrong. We've got it. Most people use these terms the wrong way around. So mass is actually the amount of stuff, the amount of material that's in an object, and that's measured in kg. Whereas weight is the force due to gravity that's basically pushing it down against the ground. So weight is, because it's a force, it's actually measured in newtons with an N. So when you say you weigh 60 kg, well, you're actually using the term incorrectly. Your mass is 60 kg, your weight would actually be 600 newtons. Now, on Earth, they're kind of the same thing, or they go hand in hand, because if you double the amount of mass, if you've got twice as much stuff, that you're made out of, your weight would be twice as much too. But it gets a bit different if we, for instance, head out into space, because in space, your mass, the amount of material that you're made out of, doesn't change, but you become weightless, right? Your weight would become zero. So essentially, the difference is subtle here on Earth, but it does, if on another planet or out in space where the force due to gravity is different, your weight would actually change. So just be aware of that. Keep thinking about that as mass is the amount of matter, the amount of stuff that's inside an object, and basically the mass doesn't change. Unless we start hacking off limbs and things, our mass wouldn't change. But weight is the force that's due to gravity that's pushing us down into the ground. So mass measured in kgs, weight measured in newtons, being the force. Now, to work out the weight of an object on Earth, we simply take its mass times 10. Now, there's a little bit of we've simplified that a little bit. The value that we use here, 10, it's actually 9.8 something, but in year 11 in NCEA level 1 science, you're allowed to just use the value 10. So we'll look at, there's actually a triangle that goes with this that can be used, that some of you might find useful. So if we have a look here, there we go. Alright, we can say that, so my triangle here, force, this is the weight force, so your weight is equal to your mass times gravity. Now you remember, guys, your mass is the thing that doesn't change unless we start hacking off limbs or something like that. So your weight force, if you were, for instance, 60 kg, would be 60 times 10. So on Earth we can use this value 10. It's actually 9.8 something, but we can use the value 10. And you'll actually find on the front of your exam book it'll say G is equal to 10 along with your formulas somewhere. So your weight force, if you're 60 kilos, your weight force is 600 newtons. And that makes it really easy to remember. Basically, guys, any question in your exams, if you get a mass of some object, if it says the mass is 600 kilos times by 10, 6,000 newtons. If the mass is 3 kilograms, the weight is going to be 30 newtons, just times by 10. But let's have a quick look, just worth mentioning what the values actually are. So we've got here is obviously your weight force, so that's measured in newtons, the unit newtons. This is the mass, so that's the unit that's used as kilograms, kg. Now the unit for gravity can either be, you can either use newtons per kg, which kind of makes sense because we can see here we could rearrange the formula so that gravity is equal to force per divided by mass, so newtons per kg. Or the other value we can use is meters per second per second. And actually that's a unit for acceleration. Well, think about it here, guys. If we put an A here for acceleration, well, that's our force equals mass times acceleration equation. So really, gravity is just a value for acceleration. It's the acceleration due to gravity. So we've got, guys, it is the same basic triangle we were using before, the force equals mass times acceleration triangle. But just remember, if you're working out the weight force of an object, it's its mass times gravity, which as far as we're concerned this year, it's times 10. Alright, now one interesting thing to note is that basically if it doesn't always work on Earth because of air resistance. Now this is a really, really unclear picture, but believe it or not, this is from one of the first landings on the moon. And our astronaut here is actually holding in one hand, he's holding a feather. So you can imagine here a wee feather. I'm not going to try and draw that well properly. And in this hand he's holding basically a hammer. While on the moon they filmed this, and he did this to illustrate the scientific concept that without air resistance the two of them will actually fall at the same rate. And that kind of makes sense when we think about it, the fact that in our formula there, the acceleration is the thing that's constant. For instance, on Earth, the acceleration is 10 meters per second, or close enough to 10. So it's even though they have a different weight force and a different mass, the acceleration is actually constant for the two objects. Now, that might seem kind of hard to believe, and I'm just going to shift that over to the side a little bit there. That might seem kind of hard to believe, but I want you to just quickly, before we move on, just want you to quickly think about two objects. I want you to imagine here I've got an object that's 10 kg and an object that's 1 kg. Now, assuming there's no air resistance, they actually fall at the same rate. Now, I know some of you will be sitting there listening going, no, I'm sure the 10 kg one will fall faster. Well, if you're convinced that the 10 kg one will fall faster, then the question I have for you is, what would happen if I tie them together? If you think the 1 kg mass falls more slowly than the 10 kg, well, when I tie them together, is it going to slow it down? Or are they both going to fall faster because the total weight is now 11 kg? Well, the answer is that basically it doesn't work, because if they did fall at different speeds, both of those answers would have to be true. If the 10 kg mass fell faster, tying a 1 kg mass should slow it down because it falls more slowly. However, because the total weight is 11 kg, it should also fall faster. And both of those can't be true at the same time, and so you can see very quickly it's not going to work. So it is really worth noting, or it is really, although it may seem it might seem odd at first, if you really think about it, it's the only way it really can work, that two objects, even if they have a different mass, they should still fall at the same rate. Assuming, if they've got the same shape and there's no difference in air resistance, then they should actually fall at the same rate. And lastly, just to recap, we should chuck that maybe in here. So guys, if we were on Earth, 10 kg mass here, well, it would be 10 times 10, alright, our value for gravity. So this would be 100 Newton. There'd be 100 Newton weight force pushing it down. And my 1 kilo mass here would be 1 times 10. So it would be a 10 Newton force pushing it down. But it's this value for gravity we're using that's actually the acceleration. So the rate at which they fall would be the same. And if you think about our force equals mass times acceleration equation, it kind of makes sense, because this one's got a bigger mass, it has a bigger force, but that's a trade-off, alright? Our mass, so if you remember, our acceleration was the force divided by mass. Well, it's got 10 times the force, but it's also got 10 times the mass. So its acceleration in this example is still, 10 times the force, but it's also got 10 times the mass. Our acceleration is 10. Over on this side, we've only got 1/10 the mass. The force, but we've also got 1/10 the mass. So it's easier to accelerate. We actually have the same value for acceleration. So guys, I hope that made some sense. The gist of it, the only thing you really need to know is that to work out the weight force, you're going to take the mass, which is in kilograms, and times it by a value for gravity, which will be on your front page of your exam or along with all the formulas. And generally for Earth, anything on Earth, we just use the value of 10 for gravity. So working out the weight force, it's the mass times 10. Cool, I hope you found that helpful.